All right, hey everybody, Mr. Forden here. I'm going to go through a few of the classroom exercises from section 4.6, which was the triangle inequality theorem. This was a new thing that we learned today in class that we talked about a bit, is that in order to just form a triangle, the two smaller sides of the triangle, the sum of their lengths, need to exceed the length of the third side. Need to be bigger than that, right? Bigger than that here. So right, remember, if you have three side lengths, let's say those side lengths of a triangle are A, B, and C, you know that the following is true, is that A plus B, if A plus B were A and B were the shorter sides, we add them together, it's going to be larger than or greater than the length of the third side, which here is C, okay? Let's say that C is a shorter side and B is the longer side. Well, then A plus C would be greater than B, for instance, okay? Now let's say that A is the longest side here. Again, right, for the general formula, we don't know what the longest side is, okay? Then B plus C, sides B plus C, their lengths would have to exceed the length of side length A, okay? So remember, we can't have super short side lengths and then connect to one really long side length. We're just gonna have like two short segments and then like a really big segment, can't form a triangle. So anyways, this allows us to deduce certain things about certain shapes. Let's look at this first one here. The base of an isosceles triangle is length 10, okay? So I'm gonna go ahead and draw that in as you guys are doing this problem, length 10. What can you say about the length of the leg? So again, visual people, people sketching things out on homeworks, you do a bit better generally in geometry. Okay, so sketching out here of length 10, you start playing with it. Okay, so I know that, for instance, yeah, the lengths of my legs need to exceed 10, need to be greater than 10. And there's really no limit to this. Okay, so remember, an isosceles triangle, I could have some huge legs, right? This could be a leg here, this could be a leg here. So I could have legs of like 50 and 50, right? That's totally okay. And then as you're drawing this out, you're remembering, oh, wait, what about an isosceles triangle? Well, an isosceles triangle, remember, has congruent legs, right? The legs are congruent. So I can do something actually specific about the length of the leg here. And what is that? Well, in order to form a triangle, okay, I would need my legs to at least sum, and more than that, right? More than 10. Look, this has to be more than 10. If it were 10 units long, I would just have to, like 10 units long, the two legs, that is, right? My legs are congruent. That up here, here. Say if that were 5 and that were 5, well, I couldn't draw a triangle like this, okay? Because if I had a length 5, well, I have to lay it over the actual, the base of the triangle and then lay it again, right? 5 plus 5 would just connect. I'd be 10 units from this point to this point, exactly 10 units. That's the only way I can connect this point to this point with 10 units of segment length, okay? So what I know about these legs here is that these legs need to be greater than 5 in length. That's what I can deduce from this, okay? That is what we have here. So the length of each leg of a leg is greater than 5. Not exactly 5, but greater than 5. Greater, larger, okay? And it can't be exactly 5, because then it would just be like, it'd be 5 plus 5 equals 10. So it'd be on top of the line there, okay? Hopefully that makes sense. I tried to demonstrate that today in class, that when we have a side length of 2, a side length of 4, we can't create a triangle with a side length of 6, right? 2 plus 4 equals 6. 2 plus 4 is not greater than 6, okay? Greater than 5 plus greater than 5, well, two numbers bigger than 5 added together would be bigger than 10, okay? Number 14, we got two sides of a parallelogram have lengths of 10 and 12. What can you say about the lengths of the diagonals? Again, draw it out, okay? So I'll draw it out here, just sketch a generic kind of parallelogram. Okay, this can be my side length of 12. This can be my side length of 10. Okay, this here is 12, right? Remember, opposite sides of a parallelogram are congruent, 10 and 10. And what can we say about the, 12, about the diagonals? Well, I can say two things about the diagonals. Let's see here. This diagonal here, this diagonal here. So what this is sort of telling you here is that regardless of how this is drawn, if I have a really extreme example, let me actually show you a really extreme example. Okay, let's make this 12. Okay, and then, you know what? Let's make this 12. Right? We'll do it like kind of, this will be where my 10 is here. Really extreme example. Let's make this 12. So what this is supposed to emphasize is that any parallelogram, unless it's a rectangle, right? Because rectangles, diagonals are congruent. Unless it's a rectangle, any parallelogram's diagonals, I'm going to have one shorter diagonal and one longer diagonal. Okay, so in the problem like this, the answer, they're going to have two criteria here. Okay, one, the longer diagonal, if I look at the longer diagonal here, okay, 12 plus 10 needs to be larger than this longer diagonal. Okay, longer diagonal here. So here, the diagonal, okay, so if I have this here, the lengths of the diagonals, let's say the length of my diagonal is x. Okay, that's the length of the diagonal. My diagonals needs to be less than 22. Where did I get the 22 from? Well, 12 plus 10 is 22. So 12 plus 10, it needs to be larger. It needs to be like if this were 22 long. No, the 12 plus 10 will be on top of the diagonal. The diagonal is distinct from the sides of a parallelogram. So this here can be up to 22, but not including 22 in length. It needs to be smaller than 22, okay? That's one diagonal. Let's look at the other diagonal. The other diagonal is very small, at least on this sort of dramatized example that we have here, okay? So if this is 10 here, there's actually something I can say about that smaller diagonal too. What can I say about that? What does it have to be, okay? Well, diagonal, right? Diagonal is either going to be the longest side in a triangle, this with the 10 and 12 here, or it's going to be one of the shorter sides, okay? One of the shorter sides here. So this side here, look, it's shorter than 12 at least, okay? If it's shorter than the 12, it actually needs to have a minimum length for this situation to kind of make sense, okay? If I'm smaller than the 12, what does this need to be here? Yes, it needs to be at least 2. Okay, right here, why does it need to be at least 2? It needs to be greater than 2. Okay, it needs to be greater than 2. Why? Well, in order to have a side length of 10 and a side length of 12, well, in order to form a triangle, the lengths of the two smaller sides, 10 plus 2, would have to be greater than the length of the third side here, 12. So 10 plus whatever this is needs to be greater than 12. So this here needs to be greater than 2. If it were 2, it's not big enough, right? It would, the 10 and then have a 2 here, but no, I need to form a triangle, okay? Because with the diagonals, they form many triangles in the parallelogram, but specifically the triangles we're thinking of is this triangle here, okay? 10 plus something larger than 2, I can form a triangle with a side length of 12, okay? So this one here is 2. 2 is less than x, is less than 22, somewhere between those, okay? And yeah, so generally with these problems here, what is this possible? Usually you have the largest it can be, and then the smallest it has to be, okay? So the largest it can be, right? It can't be 22, it's gonna be less than that. And then the smallest it could possibly be is 2. It's gonna be greater than that, okay? So this one here was just needs to be greater than 5, okay? Because there was no minimum. There was no minimum size, or sorry, maximum size for this here with 10 plus whatever number is here is going to be larger than the same number of what is here. Anyways, isosceles triangles are a bit easier. Okay, two sides of a triangle have lengths of 15 and 20. The length of the third side can be anywhere between, well, we got to think of the extreme cases. Okay, one, right, if I have a length of 20 here, okay, and I have a length of 15 over here, well, what's the maximum that third says? If I have one side's the longest here, I didn't really draw that very well. All right, this is 20. Okay, and I have a really, really long third side. So the two sides that I have kind of like this. Here. This, and I got 15 here. The length of the two smaller sides needs to be what? Needs to be greater, right? Greater than the length of the third side. So that third side can be up to, needs to actually be less than 35 in length, okay? Up to, but less than 35 in length here, okay? So we got 35, okay? Other case, right? Other case, lengths of 15 and 20, you probably thought about this one here first, is the lower, right? Like if I have a length of 20, okay? If I have a length of 20 right here, and I have another length of 15, what's the shortest the third side can be? Well, that would look something like this, right? I'd want to use that 15. Oh, no, I don't want to be on top of it, okay? Because then it would just have to be 5 here, right? I want it a little bit above in order to form a triangle, okay? So if this is 15, I still need a decent amount of distance, right? A decent amount of distance here. What is it going to be? Well, it has to be at least 5, okay? Because remember, connecting these 2 points is 20 units. So if I leave this line segment here, I need more segments. I need more length here, okay? So this length here needs to be greater than 5. Okay, so we got 5 here. Any number between 5 and 35, okay? Hey, when you're doing these problems, just use this formula, right? The triangle inequality formula right here, okay? Triangle inequality theorem. The lengths of the two sides here, 15 plus 20, needs to be greater than the third side. So it needs to be greater than 35, okay? Or sorry, 35 needs to be greater than the third side. So 15 plus 20 needs to be greater than that third side. It can be, that third side's up to 35 in units, okay? Here, if I want to double check my answer, 5 plus 15, okay, so that gets me equal to 20. So this number needs to be greater than 5. Okay, greater than 5 plus greater than 15, greater than 20. And we're good to go there. Okay. Suppose you only know that the length of one side of a rectangle is 100. What can you say about the length of the diagonal? Well, the diagonal, you think about this here, right? That's all I know. Okay, so the length of the diagonal, so this is just sort of a generic rectangle here. Okay, well, this is length 100. My diagonal is what? Well, let's think of something we can say about it. Oh, I put a right angle there. Why did I put a right angle there? Well, it's a rectangle. Okay, so length of diagonal, it's the hypotenuse of a right triangle that we have right here with a length of 100. Okay, so what I can say about the length of the diagonal here, length of diagonal here, is that it needs to be greater than 100 units. Okay, why? The hypotenuse of a right triangle is always larger than any of the legs. And we know that from the corollary, or actually not the corollary, we know it just from Theorem 419. Okay, whatever's opposite the right angle, it's going to be the largest in the triangle. Okay, because this angle is bigger than that angle, bigger than that angle. So whatever opposite is, larger than whatever's opposite in this angle here, because this is acute. Okay, let me know if you have any questions. Hope this video helped a little bit, piece this together a little bit here. Yeah, dealing with numbers, dealing with inequalities can be complicated, but we try to stay organized. We try to push ourselves, correct our work, ask questions. We get to demonstrate that we get the stuff pretty well. Unless we have any questions, take care, guys. Bye.